Most organizations treat sovereign cloud like a product you can buy. Pick a region, print the compliance pack, call it done. They are wrong. Sovereignty isn't a badge. It's enforceable authority over identity, keys, data, and the control plane that can change all three. This is the uncomfortable truth. Geography gives you residency, but jurisdiction and admin surfaces decide who can compel access and who can alter reality. In the next sections, 3 anchors: EU data boundary versus the Cloud Act, Entra policy drift, and Azure Arc control plane extension, collapse into one outcome. A default denies sovereign reference architecture you can actually verify. The comfortable lie: sovereign cloud as a product. Sovereign cloud gets marketed like a destination. You arrive, you're safe, your auditors nod, and you move on to the next procurement cycle. That story persists because it's convenient. It lets leadership treat sovereignty as a procurement property, a SKU, a region, a checkbox, a contract addendum. The platform does not work that way. Azure and Microsoft 365 are not a set of independent national clouds with neat borders. They are industrial-scale multi-tenant systems with a shared control plane design philosophy. Centralize orchestration, decentralize consumption, and enforce boundaries through identity, policy, and cryptography. That design is not evil, it's how you get hyperscale. But it means sovereign can only ever mean one thing. You can prevent changes and access you did not authorize, not detect them, not read a transparency report after the fact, prevent them. Here's what most people miss. Residency, sovereignty, and independence are 3 separate problems that get intentionally blended into one word. Residency is about where data at rest lives and where processing happens by default. Sovereignty is about who has decision authority over access, decryption, and administration. Independence is about whether your operation continues when the provider, the network, or the political climate turns hostile. Those are not synonyms, they are a stack. And if you don't separate them, you get the comfortable lie. We're sovereign because our data is in region. The easiest way to prove the lie is to ask a boring question. Who can change the system? In Azure, the control plane is Azure Resource Manager. Every create, delete, update, tag, policy assignment, role grant, key vault change, everything that matters flows through that plane. In Microsoft 365, the equivalent reality is spread across admin centers, APIs, and Entra, but the principle is identical. There is an admin surface that defines truth. If you don't control that surface, you don't control the system. You're renting it. Now watch what happens in real organizations. They start with sovereign intentions. EU-only storage, strict admin boundaries, enforced MFA, customer-managed keys, limited external sharing. Then the entropy generators arrive. A legacy application can't do modern auth, so it gets excluded from conditional access. A vendor insists on persistent access, so you add a guest account and temporarily allow it. A global support team needs emergency access, so you create break glass accounts with broad roles. A project needs speed, so you let contributor become owner, just for this subscription. A workload needs replication, so someone turns on geo-redundancy without reading where it lands. None of these are individually catastrophic. Collectively, they convert a deterministic security model into a probabilistic one. That distinction matters. Marketing promises sovereignty as a static state. Architecture experiences sovereignty as continuous degradation unless you design for enforcement. Auditors rarely help because many audits reward documentation over authority. If you can show a policy, a diagram, and a set of contractual commitments, the control often gets assumed. But the system doesn't run on your diagram. It runs on token issuance, policy evaluation, role assignments, and key release paths. This is why sovereign cloud as a label is so attractive. It lets people stop thinking at the wrong layer. EU data boundary commitments improve default routing and constrain processing locations for covered services. Good. But a boundary is still a boundary drawn by the provider's operating model. It is not the transfer of authority. The authority question remains. Who can compel the provider? Who can operate the admin plane? And, when compelled, whether the resulting data is intelligible. Identity makes the lie even more obvious. Entra isn't a passive directory. It's a distributed decision engine that continuously issues portable authority in the form of tokens. Whoever controls token issuance controls access reality across Azure M365 Power Platform and everything federated into that tenant. You can place mailboxes in a geography and still lose sovereignty because the identity and admin decisions that govern that mailbox remain globally operable through the control plane. And then hybrid arrives, with Azure Arc promising consistent governance everywhere. Arc is useful. It also extends the control plane into places you used to consider sovereign by default. Your data center, your factory, your edge. Outbound-only HTTPS doesn't create sovereignty. It creates reachability. If your enforcement model depends on a remote control plane, then your sovereignty posture now includes that dependency chain, identity availability, policy delivery, agent integrity, update channels, telemetry paths, and the humans who can operate them. So the lie isn't that sovereign offerings exist. The lie is the implied completeness, the implied finality, the implied guarantee. Sovereignty is not something you buy, it's something you enforce continuously against entropy. In architectural terms, it is a control problem, reduce external authority, constrain admin surfaces, custody keys where the provider cannot release them, and make policy drift reversible. Next, sovereignty gets broken into layers you can actually verify, because if you can't verify it, it's just branding. The sovereignty stack, 5 layers you can actually verify. Sovereignty stays vague on purpose. Vague things sell well. They also fail quietly because nobody can test them. So this section does the unglamorous part. It turns sovereignty into 5 layers you can verify, argue about, and assign ownership to. And yes, ownership matters. If nobody owns a layer, Entropy owns it. Layer 1 is legal and jurisdictional sovereignty. Who can compel whom? This is not where the data center is. It's the set of courts that can serve orders to the entity operating the service, plus the treaties and challenge mechanisms that shape what happens next. A provider can publish transparency reports and say they fight requests. Fine. The question is simpler. When a lawful order arrives, what is the enforceable outcome? If the answer is the provider can be compelled to produce customer content, then geography didn't solve the core sovereignty problem. It just changed the logistics. Jurisdiction eats geography, always. Layer 2 is identity sovereignty. Who issues tokens and who defines trust? Most organizations still talk about identity like it's a phone book. It isn't. It's an authorization compiler. It takes signals, policy, and context, and emits a token that downstream services treat as truth. If your identity platform can be operated, modified, or bypassed through admin roles you don't tightly constrain, then your sovereignty posture is already soft. Because every other control, data access, admin access, API access, rides on those tokens. If you don't have deterministic control over token issuance, you don't have deterministic control over anything else. Layer 3 is control plane sovereignty, who can create, alter, and destroy resources. Azure Resource Manager, Microsoft 365 admin endpoints, Graph, partner delegated admin, these are not management conveniences. They're the reality editing interfaces. Whoever can assign roles, change policies, create exemptions, rotate keys, approve support access, or modify network boundaries controls the system's truth. A sovereign design doesn't just log those actions, it constrains who can perform them, from where, under what approvals, and with what blast radius. If the answer is a global admin can do it, then your sovereign boundary is just a story you tell yourself. Layer 4 is data plane sovereignty, where data sits, replicates, and gets processed. This is the part most people overfocus on because it's the only part cloud marketing can simplify into a map. But data plane sovereignty is still real because replication settings, service-specific residency rules, and cross-region processing behaviors are how EU only turns into EU mostly. This layer is where you prove that storage stays in approved geographies, backups don't escape, diagnostics don't exfiltrate content, and disaster recovery doesn't quietly cross a border. The point isn't paranoia. The point is determinism. You can point to configuration and say, this cannot happen. Layer 5 is cryptographic sovereignty. Who holds keys and who can cause decryption? This is the layer that decides whether compelled disclosure produces usable data or encrypted noise. Encryption at rest is baseline. Customer-managed keys are better. External key custody, where key release requires conditions the provider can't satisfy alone, is the boundary that turns jurisdictional pressure into a technical limitation. The practical test is brutal. If the same admin surface that governs your tenant can also grant access to keys, you didn't move authority. You moved paperwork. Now here's the part that makes people uncomfortable. These layers are not independent. They're a dependency chain. Legal pressure targets the provider. The provider's leverage lives in identity and control plane operations. Those operations can change data plane behavior. And cryptography either blocks the last mile of disclosure or it doesn't. That's why sovereignty cannot be solved by residency commitments alone. So the verification model becomes straightforward. For each layer you ask, what are the control points? Who can operate them? What evidence proves enforcement, and what failure mode exists when humans do human things. Next, start where strategies usually die, law and jurisdiction, because if the legal layer can compel action, then your entire architecture has to assume that pressure will arrive eventually. EU data boundary, what it promises, what it doesn't. The EU data boundary exists because the market finally forced an honest question. When you say European data, where does it actually go? The answer used to be messy. The boundary is Microsoft trying to make it less messy by committing that for covered services, customer data storage and processing stay inside the EU and EFTA footprint unless the customer explicitly configures otherwise. That's the promise, and it's a useful one. It reduces accidental cross-border processing. It makes default routing more predictable. It gives compliance teams something concrete to reference beyond "trust us, it's distributed." For a lot of organizations, that's enough to stop the bleeding. Fewer awkward data flow diagrams, fewer exceptions, fewer late-night calls with privacy counsel asking why telemetry or support data ended up elsewhere. But the boundary is not sovereignty. It can't be. It's still a provider-defined operating commitment applied to a provider-owned platform. Here's the foundational misunderstanding. The boundary answers where, not who. It constrains geography. It doesn't transfer authority. Microsoft can build systems so that a mailbox, a SharePoint site, or an Azure service does its storage and processing inside Europe. Good. That improves residency, and it reduces the number of transits you have to justify under GDPR and related regimes. But the corporate domicile of the provider doesn't change. The legal entity receiving orders doesn't change. And the administrative reality, the control plane surfaces, and the people who can operate them doesn't automatically change just because your bits stayed in Frankfurt. That distinction matters. The boundary also doesn't magically make your tenant deterministic. It creates a default. Your architecture still creates exceptions. If you enable cross-region replication, geo-redundancy, global services, third-party integrations, or temporary support pathways, you can punch holes through a geographic commitment faster than any regulator can read your policy binder. And yes, some of those holes are legitimate. Business continuity is real. Global collaboration is real. But don't confuse "we can configure it" with "it can't happen." In sovereignty terms, configuration is the weapon. It's also the weakness. Another uncomfortable point, identity doesn't become European just because your workload data does. Entra's tenant geo-selection affects where directory objects replicate and where token issuance processing occurs, mapped broadly into a small number of geographies. There's also a global gateway layer because it's a global service. So the sign-in path can touch infrastructure close to the user and then forward to the tenant's geo. That's not a scandal, it's how global identity works. But it is a reminder, sovereignty arguments collapse when they rely on simple maps. The system is a distributed decision engine. Decisions route, signals route, evaluations happen where the system is built to run them. So what does the EU data boundary actually improve in practical architectural terms? It improves the data plane default for storage and processing for covered services. It reduces surprise processing, and it gives you a stronger baseline so your own controls can focus on fewer edge cases. It also aligns with the reality that most enterprises aren't trying to build hermetically sealed national clouds. They're trying to pass real audits without lying. That's still not sovereignty. Because sovereignty requires that if the provider is compelled or if an internal admin goes rogue, the system cannot yield intelligible data or irreversible control without your explicit participation. The boundary does not provide that. Cryptographic custody and control plane minimization provide that. And the boundary doesn't remove operational dependency. Your service still depends on Microsoft's global engineering organization, Microsoft's update pipelines, Microsoft's identity control plane, and Microsoft's incident response model. You can get additional operational controls, things like customer lockbox-style approval flows and region-restricted support models, but those are governance layers on top of a platform you do not operate. They help, they don't invert authorities. So treat the EU data boundary as what it actually is, a residency and processing constraint that reduces cross-border exposure by default. That's a meaningful improvement. It's also not a legal shield. It's not an independence guarantee. And it's not proof of sovereign control. The right way to use the boundary is to stop pretending it ends the conversation. It starts it. Because once you accept that geography is only one layer, the question becomes inevitable. If jurisdiction can still reach the provider, what stops compelled access from producing usable output? And now the architecture has to talk about keys. Cloud Act, reality check. Jurisdiction eats geography. The Cloud Act is where the sovereignty conversation stops being philosophical and becomes contractual physics. Not because it gives anyone free access, it doesn't. It's a legal mechanism that lets US law enforcement compel US technology companies to produce data in their possession, custody, or control, even when that data is stored outside the United States, subject to warrants and a judicial process. That last part matters because people love extremes. One camp treats it like a backdoor, the other treats it like it's irrelevant because our data is in the EU. Both positions are lazy. Here's the simple version. Geography controls where the bits sit. Jurisdiction controls which courts can force action on the entity operating the system. If Microsoft can be served, Microsoft can be compelled. And if Microsoft can be compelled, your architecture must assume a scenario where the provider receives a lawful order and has to respond. Not hypothetically, eventually. The most common failure mode is the Frankfurt fantasy. Someone says our data is in Germany, therefore the US can't touch it. That's not how jurisdiction works. Data location can affect which laws apply and which conflicts exist, but it doesn't automatically remove the provider from legal reach. Jurisdiction isn't a GPS coordinate, it's a relationship between courts and corporate entities. So what happens when legal systems collide? There are challenge mechanisms. Providers can contest orders that conflict with another country's laws, and there are frameworks for international cooperation. That's real. And Microsoft has a track record of challenging requests in court when they believe a demand is overbroad or unlawful. But architects don't build systems around corporate blog posts and hope. They build around worst-case enforceable outcomes. Because the only sovereignty question that survives incident reviews is, if the provider is forced to produce data, what exactly do they hand over? There are three possible answers. One, they hand over plaintext content. That's not sovereignty, that's compliance with a warrant, and your residency story doesn't matter. Two, they hand over ciphertext, but they also hold or can obtain the keys through the same administrative pathways they operate to run the service. That's better optics, not better control. Encryption without custody is still a provider-mediated decryption event. 3. They hand over ciphertext that remains unintelligible because key release requires conditions the provider cannot satisfy alone. That's the first time the legal boundary becomes a technical boundary. That distinction matters. People keep trying to solve a jurisdiction problem with a geography control because geography is something IT can configure. Jurisdiction is something legal counsel debates. So the enterprise does what it always does. It over-indexes on what it can click. But if you're serious about sovereignty, the Cloud Act forces you into a different design posture. You assume compelled access is possible. Therefore, your objective becomes minimizing what compelled access can yield. And no, this doesn't mean Microsoft can always read your data. That's not the claim. The claim is structural. If the service can decrypt and serve data to users, there exists a decryption path. The question is whether that path is exclusively under customer authority or whether the provider can activate it under lawful compulsion or internal control plane privilege. This is also where transparency hits its limits. Transparency reports and customer notifications are governance mechanisms. They are not enforcement mechanisms. If you can't technically prevent a decryption event without your participation, your sovereignty posture depends on provider behavior and legal outcomes. That's a probabilistic model. And the irony is, organizations that demand sovereignty usually can't tolerate probabilistic security models anywhere else. They don't accept will probably detect it for admin compromise they design to prevent. But for legal compulsion, they suddenly accept Microsoft will fight it, as if fighting is a control. It is not. So the right framing is blunt. The Cloud Act doesn't make sovereignty impossible. It makes sovereignty expensive because it forces you to invest in cryptographic and operational controls that reduce provider authority. Customer-managed keys are a step. External key custody, secure key release, and attestation-bound decryption are the real step. And once you do that, a lot of the marketing noise collapses because you stop asking, is the region sovereign? And you start asking, can the provider cause decryption? Can they change policy? And can they mint authority without me? If the answer is yes, you have residency. You have compliance paperwork. You have a subscription. Next, the conversation goes where people avoid it. Encryption is not the point. Encryption without custody is theater. Everyone agrees on encryption now, which is how you know it stopped being the differentiator. Azure encrypts storage at rest by default. Microsoft 365 encrypts service data. Transport is encrypted. That's baseline hygiene, not sovereignty. It reduces casual exposure and it closes off a whole category of lazy attacks. Good. But sovereignty doesn't care about whether the disk is encrypted. Sovereignty cares about who can cause decryption. That's the part people keep skipping because it's uncomfortable and it ruins simple narratives. If a provider can be compelled or if an internal admin path can be abused, the question becomes, when they reach for your data, do they get readable content or encrypted noise? Encryption at rest, implemented entirely inside the provider boundary, is not an answer. It's the provider reassuring you that they're competent. That's useful. It's also not a transfer of authority. So the next step is customer-managed keys. CMK sounds like sovereignty because the word customer is in it. And yes, it is better than platform-managed keys. You control rotation, you can implement your own lifecycle rules, you can separate duties, you can prove to auditors that keys aren't just a hidden provider implementation detail. But CMK still fails the sovereignty test in a predictable way. Too often, the key is still governed by the same administrative ecosystem you're trying to constrain. If the same tenant roles that can grant access to SharePoint can also grant access to Key Vault, then the key is not an independent control. It's a feature inside the same blast radius. You didn't build a boundary. You added a new toggle to the control plane. And the control plane is where authority lives. The simple version is, if Microsoft can operate the service, Microsoft has operational pathways. If your keys live in a service governed by that same operational model, then lawful compulsion and operational privilege don't disappear. They get rerouted. The encryption story becomes an exercise in who can click what, in which portal, under which role. That's not sovereignty, that's conditional comfort. Cryptographic sovereignty starts when custody moves outside the provider's unilateral reach. That can mean external key management, it can mean a customer-controlled HSM, it can mean a model where key release requires a decision the provider cannot make on their own, even if they operate the hosting environment. This is the garbled ones and zeros test, not as a slogan, as an architectural acceptance criterion. If the provider is compelled to export your data, the exported data must be cryptographically useless without your explicit key release. That implies two non-negotiables. You hold the keys and you control release. Custody without release control is still theater, because a key that you own but that can be activated through a provider-mediated admin path is functionally a provider key with extra paperwork. Release control is where the argument becomes real. You define the conditions under which decryption can occur, and those conditions aren't satisfiable by the provider alone. Here's the weird part. Most enterprises sabotage this themselves. They implement CMK, then they grant broad administrative access because operations needs it, or they build emergency break glass that includes key access because otherwise recovery is hard, or they let automation run with privileges that quietly include key permissions because pipelines must deploy. Every one of those is an entropy generator, and over time, the keys stop being a boundary and become another object in the same governance swamp. If you want a deterministic model, you treat key authority like a separate plane. Separate identities, separate admin workflows, separate approval chains, separate logging, separate break glass, and ideally, separate infrastructure custody. The goal is simple. An attacker who compromises your cloud admin surface should still not be able to decrypt your crown jewels. And a provider responding to a lawful order should still be unable to produce intelligible content without your participation. Now, there's an obvious objection. Fine, but the service has to decrypt data to do its job. Correct. That's why sovereignty is hard. The workload must run somewhere, and somewhere in the execution path plaintext exists, which means encryption alone doesn't solve data in use, and it solves data at rest and data in transit. Those matter. They're just not the final layer. And encryption also doesn't solve control plane abuse. You can keep data encrypted and still lose sovereignty if an operator can change policies, create new principals, mint tokens, assign roles, or exfiltrate decrypted outputs through legitimate application pathways. The system can remain encrypted and still be owned. So treat encryption properly, as a necessary layer that only becomes sovereign when custody and release control move beyond provider authority and when admin surfaces can't trivially rewire that control. Next, the architecture has to address the part encryption can't touch. Who can access plaintext while it's being processed? That's where confidential computing stops being a marketing bullet and starts being a sovereignty tool. Confidential computing, shrinking the trust you must place in the provider. Confidential computing exists because encryption keeps failing at the same moment every time when the workload runs. Data at rest is ciphertext on disk. Data in transit is ciphertext on the wire. But data in use is plaintext in memory being processed by a CPU you don't own on a host you don't administer under an operational model you can't fully observe. That is the sovereignty gap. So basically, confidential computing uses hardware-backed trusted execution environments, TEs, to create a boundary inside the machine. The hypervisor can't peek. The host admin can't dump memory. The cloud operator can't just access the box because the box is built to lie to them, not by policy, by silicon. And that distinction matters because it moves sovereignty from trust the provider's processes to verify the provider's execution state. TEs aren't magic. They don't make you independent. They don't eliminate legal reach. They do one specific thing. They shrink the trust you must place in the provider by removing entire classes of operator access from the threat model. If you're trying to build a deterministic architecture, that's the first time you can say something concrete. Even if someone gets privileged access to the host environment, they still can't see the plaintext your workload processes, assuming the workload runs inside an attested enclave and you didn't sabotage the model yourself. The lever that makes this real is attestation. Attestation is the system proving what it is before it gets access to secrets. In other words, show me your measurements, show me your firmware state, show me the launch policy. Then, and only then, do you get the key. That is how secure key release stops being a buzzword and becomes a design. Your key store, key vault, managed HSM, or an external HSM doesn't release the decryption key because the request exists. It releases the key because the runtime state matches the policy you defined. If the host is patched wrong, if the image hash doesn't match, if debugging is enabled, if the TE isn't actually the TE you approved, no key. The simple version is keys only flow into verified execution. That changes the Cloud Act conversation in a way that's actually useful, not legally, architecturally, because even if data export happens, and even if someone tries to replay the workload elsewhere to decrypt it, the keys don't follow unless the environment attests correctly. You're no longer relying on Microsoft won't do it. You're relying on the system can't do it unless these conditions are true. Now, Reality check. Confidential computing is not a universal setting you flip on the tenant. First limitation, SKU availability and regional availability. TEs show up in specific VM families and configurations. They don't exist everywhere you want them, and they don't exist for every managed service you wish would support them. Sovereignty strategies die here all the time because someone designs a perfect model on a whiteboard and then discovers their critical workload runs on a managed service with no enclave story. Second limitation, operational complexity. You introduced a new class of failure modes. Attestation fails, hosts roll forward, images drift, extensions break measurements. Your deployment pipeline now owns cryptographic properties it didn't understand yesterday. That's fine, but it means sovereignty isn't a procurement initiative anymore. It's engineering work. Third limitation, audit comprehension. This is the quiet killer. Most audit programs understand residency. Many understand encryption, very few understand attestation. So teams implement Ts, then fail to produce evidence that an external reviewer can interpret. Therefore, the control gets treated as nice to have. Therefore, it gets de-scoped later in the name of simplicity. That's architectural erosion, just with newer vocabulary. Confidential computing also doesn't remove the need for key custody discipline. If you release keys into enclaves, but the policy governing release can be changed by the same admin surface you're trying to constrain, you're back to theater. The whole point is that the release policy itself becomes a sovereign control point, locked down, reviewed, versioned, and constrained to a minimal set of identities and workflows. So where does this actually fit in the sovereignty stack? It is the data in use control, the layer that turns trust our operators into verify this measured runtime. The layer that gives you a story that survives pressure, legal pressure, insider pressure, and inevitable human configuration drift, because the system refuses to decrypt outside of the state you declared acceptable. And once you accept that, you'll notice the pattern. Sovereignty keeps collapsing back into the same primitive decision authority. Who can cause access? Who can cause change? Who can cause decryption? Which means the next failure point is predictable. Even with perfect cryptography and protected execution, identity can still mint authority, root around your intent, and turn your sovereign design into a permission mistake at scale. Entra isn't an identity provider, it's a distributed decision engine. Most organizations still describe Entra like it's a directory, a corporate phone book with passwords. That framing is comforting because phone books don't make decisions, they just sit there. Entra does not sit there. Entra is a distributed decision engine that continuously manufactures authority and hands it to everything else. Azure, Microsoft 365, Power Platform, partner apps, your line of business apps, and an embarrassing number of temporary integrations that became permanent in 2019. The output of that engine is the token. And a token isn't identity. A token is portable permission. It's a signed statement that says, this principle is authenticated, these claims are true, these conditions were met, and for the next slice of time, the downstream service should treat this as reality. That's why the phrase identity provider is misleading. Entra doesn't just prove who you are, it decides what you're allowed to do, and it publishes that decision as a bearer artifact that other systems don't second guess. That distinction matters because sovereignty collapses the moment token issuance becomes non-deterministic. If the system can mint authority from a compromised device, from an excluded user, from an unscoped admin role, or from a policy exception someone forgot existed, then your sovereign data plane controls don't matter. Your encryption story doesn't matter. Your region choice doesn't matter. The platform will faithfully enforce the wrong decision at hyperscale. And Entra runs at hyperscale. Now tie this back to geography because this is where people assume they made a sovereign choice by selecting a country during tenant creation. That choice does matter, but not in the way executives think. Tenant geo-selection governs where directory objects are stored and replicated, and where core processing occurs for token issuance, broadly mapped into a small number of geographic locations. In practical terms, most tenants land in one of the big four buckets: United States, Europe, Asia Pacific, or Australia, with a few special case environments. So yes, you can control where the identity objects live and where the authoritative processing happens. But here's the caveat nobody puts in the slide. Entra is a global service with a global gateway layer. Users authenticate against a nearby gateway. Then the request gets forwarded to the tenant's geo for evaluation and token issuance, and the response comes back. That isn't a loophole. It's the design required for performance and availability. And it's also why sovereignty arguments that rely on nothing ever touches outside region X collapse the moment you look at actual sign-in flows. More importantly, the sovereignty implication isn't that packets traverse a global gateway. The implication is that your boundary is not a wall, it's a decision pipeline. Tokens get issued based on dependencies you don't always treat as sovereignty critical. Device compliance, MFA registration state, risk signals, conditional access policy evaluation, authentication strengths, session controls, continuous access evaluation signals, and the service's own interpretation of claims. That is a supply chain. It's just invisible, so people pretend it's simple. This is why executives misunderstand identity sovereignty. The word directory sounds passive. The admin center UI looks like a list of users and groups. Meanwhile, the system is compiling authorization decisions in real time, at global scale, with a rule set that grows through exceptions, because humans optimize for business continuity, not determinism. And once Entra becomes the perimeter, sovereignty becomes an identity architecture problem before it becomes a data architecture problem. Who can create an app registration that bypasses your intended flows? Who can grant admin consent? Who can add a federated credential? Who can change conditional access? Who can exclude break glass and then reuse it for convenience? Who can mint tokens with claims that downstream services accept without context? Those are not operational trivia. Those are sovereignty controls. So the correct mental model is blunt. Entra is your authorization compiler. Conditional access is not extra security. It is part of the compilation pipeline. The token is the compiled output, and every downstream workload treats that output as truth. If you want sovereign control, you don't use Entra. You govern token issuance like it's a national border checkpoint. Minimal exceptions, explicit authority, auditable change, and an assumption that anything not enforced by design will erode. Next, the place determinism goes to die is predictable. Conditional access drift. Conditional access drift. How determinism dies. Conditional access looks deterministic on paper because it's written like code, if this then that. Require MFA, block legacy auth, allow only compliant devices, force a sign-in from trusted networks. The UI makes it feel like you're building a tight little rules engine that turns messy human behavior into predictable enforcement. That's the sales pitch. In reality, conditional access is a policy layer glued onto a living tenant, and the tenant is always changing. New apps, new endpoints, new identities, new compliance demands, new business exceptions. The system doesn't drift because admins are careless. It drifts because organizations optimize for uptime and convenience. And conditional access is where those compromises get encoded. Here's the uncomfortable truth. Every exception is an entropy generator. At first, it's reasonable. You block legacy authentication, then a scanner or line of business tool breaks, so you exclude a service account. You require compliant devices, then a contractor shows up with a personal laptop, so you create a group-based carve-out. You force MFA, then an executive complains about prompts while traveling, so you add a trusted location rule that quietly becomes the hotel Wi-Fi exemption. You mandate modern authentication strength, then an app can't handle it, so you add an authentication method exception temporarily. Temporary is not a state, it's a timeline. And conditional access has no mechanism that prevents temporary from becoming permanent. It will happily enforce whatever sprawl you feed it. Over time, the policy set stops reflecting intent and starts reflecting history. Every past outage, every vendor argument, every half migration, every acquisition, every "we'll clean it up later." That's how determinism dies, not with a breach, with accommodation. The failure isn't just that there are many policies. The failure is that policy interaction becomes non-obvious. Policies target different scopes, conditions overlap, exclusions stack, and your sign-in decision becomes a composite of rules nobody can reason about quickly during an incident. And when people can't reason about a system, they stop improving it. They freeze it. Then they layer more exceptions on top. You can see this in how teams treat break glass accounts. The original idea is sane, an account that survives when MFA or conditional access is broken. But then it gets excluded from policies, granted broad roles, and stored in a password manager accessible to too many people because it's an emergency account. Eventually, it becomes a standing bypass. You didn't build resilience. You built an unmonitored backdoor with a great name. Partner access does the same thing. B2B users need access. Managed service providers need delegated admin. A vendor needs to integrate. Every one of these starts as a controlled relationship. Then the urgency arrives and someone chooses speed. Invite the guest, add them to a group, exclude them from a policy because their phone can't do it, and move on. Your sovereign posture didn't get attacked. It got negotiated away. And then there are risk signals. Risk-based conditional access can be useful. Sign-in risk, user risk, session controls, continuous access evaluation. It's a better model than static IP allow lists and VPN equals trust, but it introduces probabilistic inputs into your enforcement layer. The system starts making decisions based on ML-driven assessment and real-time heuristics. That's fine for reducing account takeover. It's not fine if your sovereign model assumes deterministic enforcement paths, because now you've mixed hard controls with soft signals. You've told your auditors you block non-compliant access, but you've also told the platform it can adapt based on risk. That's not wrong. It's just a different security model than most sovereignty narratives admit. Sovereignty once cannot. Risk engines are built around likely. The second-order problem is token lifetime and session behavior. Conditional access often evaluates at sign-in, then the token lives long enough to outlast your intent. Continuous access evaluation helps, but it's still a system of signals, revocations, and downstream service behavior. If the workload doesn't respect the signal quickly, your deny becomes deny later. That's not a boundary, that's a suggestion. So the real lesson is blunt. Conditional access isn't your sovereign boundary, it's the compiler front end for your token supply chain. If it drifts, the compiler emits authority you didn't intend, and every downstream service will obediently accept it, which means the only sustainable posture is minimalism and reversibility. Fewer policies, fewer exclusions, explicit scoping, and a design expectation that drift will happen unless you structurally prevent it. Next, that token supply chain gets made visible, because sovereignty fails on the dependencies you can't see. The token supply chain, sovereignty depends on invisible dependencies. Here's what most sovereignty discussions conveniently ignore. Tokens don't appear out of thin air. They come from a supply chain, and like every supply chain, it has upstream dependencies, transit paths, transformation steps, and downstream consumers that each interpret the artifact slightly differently. Sovereignty fails in the gaps between those steps. Start with the sign-in flow. A user doesn't sign into Entra. They hit a gateway that's close to them, because latency matters and global services don't route every request back to your chosen geo first. The gateway brokers the conversation, then forwards the authentication and policy evaluation to the scale units that own your tenant's authoritative processing. Then a token gets minted, signed, and sent back through the same plumbing. Nothing about that is suspicious. It's just distributed systems. But it means your boundary isn't a fence around a data center. It's a pipeline that spans locations and components you don't administer. Now look at what that pipeline depends on. Device compliance isn't a checkbox. It's an entire attestation story. In-tune enrollment state, device health reporting, certificate presence, TPM claims, platform trust. If compliance signals go stale or get spoofed, the token gets minted anyway unless you explicitly designed for that failure. And when the token gets minted, the downstream service doesn't know the device lied. It just knows the token says compliant. Risk scoring isn't a feature, it's another dependency chain. Identity protection detections, sign-in risk calculations, IP reputation, impossible travel heuristics, and whatever else the service can infer. Those are probabilistic signals feeding a deterministic enforcement narrative. If your sovereignty model assumes no access outside conditions, but your access decision includes ML-based uncertainty, you built a boundary out of confidence intervals. Conditional access itself isn't one decision. It's an evaluation graph, user scope, app scope, authentication strength, session controls, location conditions, exclusions, and sometimes multiple policies applying at once. You can read the policy list. You can even export it. What you can't do quickly is reason about the emergent behavior once the tenant accumulates history. That's why drift is structural. The compiler still compiles. It just compiles the wrong thing. Then come the downstream consumers. A token is a contract between Entra and the service. But each service reads that contract differently. Some respect continuous access evaluation rapidly. Some lag, some cache, some accept claims in ways you didn't predict. Some services gate sensitive operations with additional checks. Others treat the token as absolute truth until expiration. So your sovereign boundary becomes a moving system. Part identity, part service behavior, part token lifetime policy, part session enforcement. That's the uncomfortable truth. Sovereignty depends on how everyone in the ecosystem interprets the token, not just how you issue it. And the invisibility is the problem. Most enterprises track network routes, storage accounts, and regional settings because those are tangible. They do not track token lifetimes, claim sets, evaluation dependencies, and revocation behaviors as sovereignty controls. So the first time they discover a gap is during an incident when someone says, "We blocked access," and the attacker says, "Cool, my token still works." Continuous access evaluation helps, but it doesn't turn this into a hard boundary. It turns it into a faster feedback loop. That's not the same thing. If you need deterministic sovereignty, you design for the worst case. Tokens remain valid longer than you want, revocations propagate slower than your policy narrative implies, and downstream services don't all react uniformly. And then there's workload identity. Service principals, managed identities, federated credentials, automation accounts, these are token factories without humans attached. They're efficient. They're also sovereignty liabilities when you treat them like plumbing. A CI/CD pipeline with broad graph permissions can mint authority at machine speed. An overlooked app registration can hold long-lived secrets. A federated credential can let an external system exchange a trust relationship for tokens without a user ever touching a login page. That means sovereignty isn't just about people crossing borders. It's about workloads minting authority across trust boundaries you forgot existed. So the practical implication is blunt. Sovereignty fails silently when tokens outlive intent, when dependencies drift, and when services interpret claims in inconsistent ways. Your control plane can be locked down and your data can be in region, but if your token supply chain remains opaque, you're enforcing sovereignty by hope. Next, the only sane response is policy resilience. Treating identity configuration as sovereign state with backup, versioning, and rollback, because drift isn't a question of if, it's a schedule. policy resilience, backups, versioning, and the unsexy controls that actually matter. Every sovereignty program eventually discovers the same problem. The most important controls are also the easiest to delete. Not with an exploit, with a change request. Conditional access policies, authentication strengths, named locations, device compliance requirements, admin consent settings, tenant restrictions, cross-tenant access rules, break glass design. These aren't settings. They're sovereign state. They define what authority can exist in your environment and under what conditions it gets minted, and the platform treats that state like configuration, which means it can drift, it can be misedited, it can be overwritten by automation, it can be removed by an admin who thinks they're fixing an outage, it can be attacked directly, because the fastest way to win against zero trust is to change the trust rules. So the unglamorous reality is this. Sovereignty requires rollback, not documentation, not policy PDFs, rollback. Because if your control plane and identity plane are where authority lives, then restoring them to a known good state is not operational maturity. It is the control that makes everything else credible. Here's the foundational mistake. People assume it's in the cloud means it's recoverable. Cloud services are resilient against hardware failure. They're not resilient against your admins. Deletion replicates quickly. Corruption replicates quickly. Bad policy changes replicate instantly. The system does not pause and ask whether you meant it. And when identity breaks, everything breaks at once. This is why Entra configuration backup is not a nice to have. It's the difference between a deterministic model and conditional chaos. If someone introduces a bad exclusion into conditional access, you need to revert to last week's known good policy set, fast, without reconstructing it from memory, screenshots, or whatever your change advisory board pretends is an audit trail. Native history exists in places. But history exists is not the same as I can restore the tenant to a prior security state. Viewing and deleting a policy after the fact is not sovereignty. It's archaeology. So what actually matters? First, versioning. You need a record of each identity-critical object over time. Who changed it, what changed, and what the previous state was. Not just logs of policy updated, the actual content, conditions, scopes, exclusions, grant controls, session controls, the things that determine what token can be minted. Second, restore capability, not export. Restore. Export is compliance theater. If restore isn't tested, sovereignty is enforced by the ability to say that change never happened and make it true. Third, independence of the recovery plane. If your recovery tool requires the same identities and permissions that just got compromised, you didn't build resilience, you built another dependency. Recovery needs its own constrained trust path, separate admin accounts, separate approval workflow, and ideally separate credential storage that doesn't live in the same tenant blast radius. This is why third-party backup tools keep showing up in sovereignty conversations. Not because Microsoft can't build backup, because enterprises need evidence and rollback that align to audit and incident response realities. Tools like Veeam and Druva are increasingly used to back up Entra configuration objects and provide historical versioning and restore. The specific vendor is less important than the capability, durable policy history, and rapid restoration. And yes, it adds a vendor dependency, sovereignty's trade-offs. But the alternative is worse, a sovereign posture that collapses when someone clicks disable on the wrong policy. Now this connects directly to drift. Remember the drift story. Exceptions accumulate because business continuity wins. Resilience is how you keep those exceptions from becoming irreversible. You can allow a controlled deviation when you must, but you need the ability to unwind it when the emergency ends. Otherwise, every emergency becomes the new baseline. This also changes how you treat change management. Change boards love forward motion.
Sovereignty demands reversible motion.
Every identity control change should be treated like a schema migration. Planned, reviewed, deployed with a rollback plan that is actually executable and monitored for behavior changes in the token pipeline. And there's one more uncomfortable truth. The hardest part isn't backing up the objects. It's deciding which objects are sovereignty critical and treating them like crown jewels. Conditional access policies are obvious. But so are app registrations with high privileges, admin consent grants, cross-tenant access settings, and the group memberships that scope who your policies apply to. If you back up the policy but not the group that defines its scope, you backed up a sentence without the subject. So here's the rule. If a configuration object can change who gets a token, what claims it contains, or what it can access, then it's part of your sovereign control set. Back it up, version it, test restore. Because without rollback, all your sovereignty controls are temporary, and the platform will eventually prove that to you. Control plane versus data plane, the boundary everyone pretends not to see. Most sovereignty programs obsess over the data plane because it's the only part with a map. Storage accounts live in a region. Mailboxes live in a geo. Backups live somewhere you can point at in a meeting. Great. But sovereignty doesn't collapse because the bits moved. It collapses because authority moved. That's the boundary everyone pretends not to see. The control plane is where reality gets edited, and the data plane is where reality gets stored. If you don't separate those, you end up sovereign in the data plane and completely non-sovereign in the place that decides what the data plane even is. The control plane is not a dashboard. It is not a convenience layer. It is the set of APIs and admin surfaces that can create resources, change policies, grant roles, rotate keys, approve support access, and redefine network reachability. In Azure, that's ARM. In Microsoft 365, it's a messy federation of portals and graph endpoints. Same outcome. A small set of privileged pathways can rewrite the environment at speed from anywhere the provider allows. The data plane, by contrast, is where your workload actually lives. It's your storage endpoints, your database connections, your mailboxes, your SharePoint content, your files, your messages. The data plane can be region-scoped, it can be encrypted, it can be replicated with constraints, it can even be wrapped in DLP policies and retention logic. None of that matters if the control plane can still do three things: change who is allowed in, change what gets logged, and change what gets exported. This is the foundational mistake enterprises make when they claim sovereignty through residency. They treat the control plane as management traffic, therefore not sovereignty relevant. But management traffic is the only traffic that can redefine enforcement. If an attacker or an internal admin under pressure can use the control plane to add an exemption, assign owner, disable a policy initiative, or alter a key release workflow, then the data plane will obediently follow. That's not a vulnerability, that's the product. So the sovereignty definition tightens here. Sovereign control means you can prevent unauthorized change, not just detect it. Logging is important, but logs are downstream of power. An admin with control plane authority can disable logging, redirect it, scope it away, or drown it in noise. The system doesn't protect you from the identities you made omnipotent. This is also where tenant isolation narratives get sloppy. Tenant isolation can stop cross-tenant access. It can't stop intra-tenant abuse. And sovereignty failures overwhelmingly happen inside the tenant boundary. Excessive admin roles, poor PM discipline, long-lived service principles, and emergency accounts that quietly become primary accounts. So you have to treat control plane exposure as a jurisdictional leverage point, not because every order becomes action, because the control plane is the mechanism by which action can occur at all. If a provider is compelled, they don't need to move your data across borders to satisfy the order. They can operate the control plane to extract, export, replicate, or grant access depending on the service and the scenario. That's why sovereignty becomes an ability to prevent problem, prevent role grants you didn't authorize, prevent policy changes outside your workflow, prevent support access without explicit approval, prevent key release without attestation and external participation, prevent administrative actions from occurring from outside your allowed networks and devices. These are control plane constraints, not data plane settings. And here's the uncomfortable operational reality. The control plane is designed to be reachable. It's designed for global administration, automation, partner management, and incident response. The platform wants to help you recover quickly, which means it wants privileged paths that work when everything is on fire. Sovereignty wants the opposite. Sovereignty wants fewer paths, fewer identities, fewer emergency exceptions, and slower, more auditable change. So you're not buying a feature, you're choosing a failure mode. If you design for hyperscale convenience, you inherit hyperscale authority distribution. If you design for sovereignty, you accept operational friction as the price of deterministic control. This is where the earlier sections converge. Identity is the compiler, conditional access is part of the compilation process. Keys define whether disclosure yields plaintext, but the control plane is the place all of those controls can be rewritten. So if you're serious about sovereignty, you don't start with where is the data. You start with who can change the rules that define access to the data. And once you see that, Azure Arc becomes unavoidable, because Arc is the mechanism that extends the control plane into places you previously managed locally with local authority, local workflows, and local failure domains. Next, Arc as both a sovereignty tool and an entropy amplifier, depending on where you let the truth of management leave. Azure Arc, the control plane extends, so does your exposure. Azure Arc gets pitched as Azure Anywhere, which sounds like freedom. It isn't. It's Azure Resource Manager projecting authority outward, so anything you own, servers, Kubernetes, sometimes data services, can be treated like first-class Azure resources. Same tags, same RBAC, same policy assignments, same compliance dashboards, same defender hooks, same automation. That's the value proposition. One control plane to rule the mess you accumulated over 20 years, and it works. But sovereignty isn't about where the Arc works. Sovereignty is about where the management truth lives and who can rewrite it. With Arc, the management truth lives in ARM. That means your on-prem box might sit in a sealed facility under local jurisdiction, but the definition of what compliant means, what extensions get pushed, what configurations are enforced, what monitoring agents run, and what identities are allowed to operate it, those decisions now originate from a cloud control plane. You can call it policy as code. The system calls it remote orchestration. Same outcome. This is the uncomfortable truth. Arc is not a hybrid tool. It's a sovereignty trade. You gain centralized enforcement. Azure Policy can audit or deploy configurations at scale. Azure Monitor can collect telemetry in a consistent schema. Defender for Cloud can attach security posture, recommendations, and alerts. GitOps can converge Kubernetes state. Update management can schedule patches across fleets. All good things, if your primary risk is drift and your primary constraint is headcount. But the sovereignty cost is predictable. You expanded your control plane's blast radius to every environment you onboard. Arc's outbound-only HTTPS design is always mentioned like it's a sovereignty guarantee. It isn't. Outbound-only just means you don't open inbound firewall ports. It does not mean you reduced the authority of the remote system. You increased it, because now the question isn't, can Azure reach in? The question is, can your Arc-connected resource be compelled to execute actions issued by ARM identities and policies? And that's the entire sovereignty problem restated in modern terms. Arc also introduces metadata gravity. The moment you onboard a server or cluster, it becomes an ARM resource with properties: name, location, resource group, subscriptions, tags, policy compliance state, agent versions, installed extensions, assessment results. None of that is customer content, but it is operational truth about your environment. And operational truth is sensitive. It reveals what you have, where it is, how it's configured, and what's failing. That's valuable to attackers. It's valuable to auditors. It's valuable to anyone trying to map your estate. Sovereignty programs routinely ignore metadata because it doesn't look like data, then get surprised when the metadata becomes the most portable part of their architecture. Now add the dependency chain. Arc depends on Entra for identity. It depends on ARM for authorization. It depends on the Arc agent lifecycle. It depends on extension publishers. It depends on policy definitions being correct. It depends on continuous connectivity, at least for consistent reporting and enforcement. So your sovereign posture becomes coupled to a set of cloud services that you don't operate and can't fully isolate. That's not a critique, that's the mechanism. Arc is an entropy amplifier when you let global admin patterns and broad RBAC roles touch it. If a principal can assign policies at subscription scope, it can force configurations onto thousands of machines. If a principal can deploy extensions, it can install code across your fleet. If a principal can modify policy exemptions, it can create exceptions that look compliant while disabling enforcement. At scale, Arc turns one bad decision into a fleet-wide decision. Deterministic sovereignty requires the opposite: narrow scopes, constrained assignments, and explicit separation between observation and mutation. Audit is not enforced. Monitor is not modified. Inventory is not admin. Arc makes that separation optional. Enterprises make it theoretical. There's also the hybrid illusion. The workload runs locally, therefore the risk is local. But Arc collapses failure domains. Your compute might be local, but your management plane is centralized, and centralized planes attract centralized pressure: legal, operational, and adversarial. So Arc can be part of a sovereign architecture, but only if you treat it like a foreign control plane with a tightly negotiated interface. Minimal onboarding, minimal permissions, minimal extensions, minimal policy surface, explicit approval workflows for any action that changes state. Explicit telemetry classification, because monitor everything is how secrets leak into logs. And explicit acceptance that Arc brings cloud control plane assumptions into places that used to survive without them. Next, the only real question is where you draw the boundaries: regional landing zones that isolate sovereignty domains, or application landing zones that optimize for unified operations and accept the exposure. Hybrid sovereignty patterns, regional landing zones versus application landing zones. Hybrid sovereignty design usually fails at the same fork in the road. Do you organize control around geography or around the application? Both patterns can work. Both patterns can also produce beautiful diagrams that collapse the first time a cross-border incident happens, and someone asks, who had authority to change this? Regional landing zones are the sovereignty-first answer. You build one landing zone per geopolitical boundary that matters to your auditors and your laws: EU, UK, US Gov, whatever your reality is. Each zone gets its own subscriptions, its own policy assignments, its own logging syncs, and ideally its own privileged access model. The intent is simple. If sovereignty is a jurisdiction problem, you align management boundaries to jurisdictions. That distinction matters because it reduces the blast radius of mistakes. If a policy exemption exists in the EU landing zone, it doesn't automatically leak into the US zone. If an admin role is granted for a specific region's operations team, it doesn't silently become global. You're turning sovereignty into a scoping primitive the platform can actually enforce. But regional landing zones create friction because reality doesn't respect your boundaries. Applications span regions. Dev teams want one pipeline. Security wants one dashboard. Executives want global visibility. So the pressure starts immediately. Can we just centralize the management group hierarchy? Can we just use one log analytics workspace? Can we just run one Arc subscription for all on-prem? Every just statement is the beginning of sovereignty erosion. Application landing zones are the operation's first answer. You group all components of an application, regardless of where they run, into one subscription model so you can apply one policy set, one RBAC model, one monitoring configuration, and one deployment pipeline. This is how modern platform teams think. The application is the unit of governance because that's what changes together. And yes, it's efficient. It's also how you accidentally build a sovereignty bypass, because now the app boundary becomes your management boundary, and the app boundary is not a legal boundary. If the application includes components in multiple jurisdictions, you've created a management scope that crosses those jurisdictions by design. The control plane doesn't care that your compliance team wanted separation. It will enforce whatever scoping you give it. So the real question is, what are you optimizing for? Sovereignty isolation or operational simplicity? You can't optimize for both. You can only decide which failure mode you prefer. Regional landing zones fail when teams reintroduce centralization through shared dependencies, shared identities, shared pipelines, shared logging, shared key management, shared global admin patterns. Application landing zones fail when teams treat sovereignty like a data-at-rest property and ignore that management authority now spans the whole system. There are also a few things that must stay local if you're serious. Keys are the obvious one. If key custody and release control defines whether disclosure yields plaintext, then keys can't sit in a shared global subscription controlled by a global admin team. They must be tied to the sovereignty domain they protect, with separate identities and separate approval workflows. Logs are next, not because logs contain data, because logs contain truth. They expose resource names, IPs, identities, failures, and sometimes payloads when someone enables verbose mode during an incident and forgets to turn it off. If you centralize logs across jurisdictions, you centralize operational truth across jurisdictions. That can violate residency policies, and it can also become a single extraction point. Approval workflows matter for the same reason. If a privileged action requires explicit human participation, support access, key release, break glass invocation, then the workflow engine, the audit record, and the identities involved must align with the sovereignty boundary. Otherwise, you've built a local data plane controlled by a foreign decision loop. And then there's break glass. Every architecture claims it has contained break glass. It never does. The typical break glass account gets created once, excluded from policies, and then quietly becomes the universal skeleton key across regions because we needed to recover quickly. Sovereign design means regional break glass with regional scope and a procedure that treats invocation as an incident, not an inconvenience. So what's the deterministic pattern? Use regional landing zones as the default for anything with jurisdictional constraints. Keys, identity control, policy assignment, and logging. Then, where application-centric grouping is operationally necessary, you project into the region, not across it. The application can be global. The sovereignty control points can't be. Everything else is governance theater. Pretty diagrams, shared admin accounts, and an audit story that depends on nobody ever making a convenient exception. And because people will make exceptions, the architecture has to assume it and constrain it. That's the actual job. Azure regions and the illusion of picking a country. Region selection is the favorite sovereignty control because it's the one thing procurement can understand. Pick Germany West Central, tick the residency box, and declare victory. The platform even reinforces the story. When you create a resource, you select a region, and Azure tells you the data stays in that geographic boundary at rest. True statement, also incomplete, and sovereignty dies in the incomplete parts. A region is a data plane placement decision. It constrains where certain bits live and where certain compute runs. It does not by itself constrain who can administer, who can compel, who can export, or who can redefine replication. The region doesn't own authority. The control plane does. And you already know where the control plane sits in this story. Wherever Microsoft operates it, with whatever legal and operational dependencies that implies. So yes, regions matter, but they're not a sovereignty product, they're a knob. Here's what most people miss. Azure offers you dozens of ways to accidentally route around your own region choice. The obvious one is geo-redundant replication. Many services can replicate across regions, sometimes by explicit configuration, sometimes by resilience features you enable because an availability requirement shows up in an RFP. You can keep everything in country until someone enables a redundancy mode that quietly crosses the boundary. The platform will do exactly what you told it to do. It will also do it forever because the system remembers your intent better than your governance does. This is why data stays in the region isn't a guarantee. It's a default that you can override. And enterprises override defaults constantly, usually under pressure, usually without revisiting the sovereignty narrative they sold upstairs. Then there are the edge cases that aren't even mistakes. Some geographies have historical replication patterns that complicate simplistic claims. Brazil gets cited a lot because, depending on service and configuration, certain replication options can target outside the country boundary. The important point isn't Brazil. The point is that region boundary assumptions are service-specific and feature-specific. Sovereignty isn't a region property. It's a configuration property across the service portfolio. AI adds a newer, quieter version of the same illusion. You can deploy AI services in a region, but the real question becomes, where does inferencing happen? Where do prompts get processed? And what residency controls exist for that processing? Microsoft has introduced concepts like data zones that restrict inferencing clusters to the US or EU for certain services and scenarios. That's useful, but notice the pattern. It's still a policy and governance problem. You have to select the right option in the right service and then prevent someone from changing it later because performance or capacity became the new priority. And capacity always becomes the new priority. There's also the architectural trap of treating country as a coherent boundary in Azure. A region is not the country. It's a specific set of data centers in a locality, and Azure pairs regions, provides availability zones, and offers services that behave differently depending on resilience modes. The map in your head is not the map the platform enforces. The platform enforces the rules of each resource provider, and those rules differ, which means the only safe statement is the boring one. Region selection is necessary for residency, but insufficient for sovereignty. If you want this to be deterministic, you treat region selection as one guardrail in a larger system. Azure policy constraints that deny deployments outside approved regions, policy assignments that detect and block cross-region replication settings, and landing zone design that makes wrong region a build failure, not an audit finding, because otherwise, your sovereignty posture depends on every engineer remembering to choose correctly forever. That is not a control model. That is a cultural aspiration. And this loops back to the earlier theme: sovereignty equals the ability to prevent. Regions help you prevent some classes of data placement mistakes. They do not prevent authority from being exercised through the control plane. They do not prevent keys from being released. They do not prevent tokens from being minted. They do not prevent Arc from projecting management across boundaries. They just constrain where the default data plane tries to live. So pick regions, enforce regions, audit regions. But stop telling yourself you picked a country and therefore solved sovereignty. You picked a storage location. The next time someone says our sovereign strategy is EU West, the only correct response is that's not a strategy, that's a coordinate. As you are local, connected, sovereignty by extension, not isolation. At some point, every sovereignty conversation hits the same wall. The public regions aren't the problem anymore. The problem is the edge case your auditors actually care about, the factory in a country where you don't want to run in the local public cloud, the site with latency constraints, the facility with regulators who don't accept it's encrypted and it's in the EU as an answer. This is where Azure Local shows up as the compromise product, not sovereign cloud. Sovereign adjacent Azure Local in connected mode gives you Azure consistent infrastructure in your building or in a trusted colocation facility. Compute, storage, networking, clustering, the stuff you'd normally build as private cloud, but wrapped in a Microsoft-supported shape so you can still use Azure tooling and governance patterns. And that's the point. It's sovereignty by extension, not sovereignty by isolation. The capacity sits under your physical control. That matters. It reduces a whole category of risks around where the disks are, who can walk into the data center, and what jurisdiction controls the facility. For some requirements, that's the primary demand. Put the hardware in country. Keep the workloads local. Prove it. But the connected model keeps the control plane relationship. Azure Local Connected uses Azure Arc to project that hardware into Azure Resource Manager. You manage it with the same resource graph, the same policy engine, the same identity stack, the same portals, and the same automation patterns. That is operationally attractive because it unifies governance. It's also the architectural reason it isn't isolation. So the sovereignty question becomes precise. Where does authority live? If the thing that can create, modify, and destroy resources still lives in RM, and the identities that can operate that control plane still live in Entra, then your sovereign posture depends on the same decision engines you already had. You moved compute closer. You did not move control closer. That distinction matters because people confuse data stays local with control stays local. Azure Local Connected only guarantees the former unless you design aggressively for the latter. There's also the support and update reality. Azure Local isn't a static appliance you install and forget. It has a life cycle. Host updates, firmware, drivers, cluster upgrades, Arc agent updates, extension updates. The connected model assumes an update channel and a management relationship. That's how it stays supported. That's also how external dependency creeps back into the architecture. You can't claim independence while your platform's health depends on a cloud-mediated lifecycle. And yes, Microsoft will tell you the connectivity is outbound only and encrypted, and that's all true. But again, outbound only isn't a sovereignty property. It's a firewall property. The more important issue is what that outbound channel enables. Orchestration, policy evaluation, compliance reporting, extension deployment, and identity-driven authorization. If your Arc-enabled environment can be altered by a principal that lives in the same tenant as your cloud estate, then your local cluster just became part of the same blast radius. This is why Azure Local Connected can be a sovereignty solution for residency requirements, but it is not the end state for no external authority. It's an intermediate architecture for organizations that want locality without giving up cloud governance and services. It also inherits the same entropy problem. The minute someone says, we'll just use the same admin group, you've already lost the sovereignty argument. The minute someone grants broad role assignments because it's just on-prem, Arc turns that into centralized privilege. The minute someone pushes monitoring agents that log sensitive data into a central workspace, you created cross-boundary truth leakage through telemetry. The system doesn't care why you did it. It just does it. So the deterministic pattern, if you insist on connected Azure local, is separation by design. A distinct landing zone, distinct subscriptions, constrained RBAC, strict PIM, and explicit policies that treat the environment as a sovereign island even though it's Arc managed. Separate key custody, separate log syncs, separate approval workflows for any change that modifies state, not just observes it. Because connected Azure local is a trade, you're buying locality, consistency, and hybrid service integration. In exchange, you accept continued dependence on the cloud control plane and the identity plane. It can be the right trade, but it is not isolation. And if your sovereignty requirement is literally no external dependencies, then connected Azure local is by definition insufficient. The system still has a remote truth, which means the next step is predictable, the disconnected model, where the control plane stops living in Azure and starts living with you. Azure local, disconnected, when sovereignty means no external dependencies. Now we get to the only version of sovereign that people actually mean when they stop using marketing language. Disconnected. Not we prefer EU regions. Not we use customer-managed keys. Not we have a partner-operated cloud. Disconnected means the system continues to operate when the outside world disappears, and no external control plane can reach in to fix or change anything. That's what sovereignty looks like when you remove optimism from the design. Azure Local Disconnected is the model where you stop projecting your environment into Azure Resource Manager and you stop relying on public Entra as the identity authority. The control plane lives with you. The identity provider lives with you. The management portal lives with you under your DNS, under your network, under your jurisdiction. That distinction matters because it finally answers the question, who can cause change with something other than whoever has global admin at 3 a.m.? In this model, Azure Local runs its own local control plane. That's the point. Your administrators talk to a local endpoint, not ARM. Your orchestration doesn't depend on outbound reachability. Your policy enforcement doesn't rely on Azure policy evaluating compliance in a tenant you don't operate. You built a cloud-shaped system that survives disconnection because the authority doesn't live elsewhere. Identity follows the same logic. Instead of Entra issuing tokens, disconnected Azure Local uses a local identity provider built on Active Directory domain services and Active Directory federation services. It's old school, and that's the quiet irony. The path to sovereignty is often walking backwards to an identity model you can physically control. You gain something real here. Token issuance authority moves into your building. If someone wants to compel access, they can't do it by asking Microsoft to mint new tokens, change conditional access, or grant a role through a cloud portal. Those levers aren't connected. They're not available. This doesn't mean you eliminated legal pressure. It means you removed the cloud provider as an execution pathway. Pressure still exists, but the system no longer has a remote actuator. And yes, you pay for that. The first cost is feature scarcity. Disconnected Azure Local is a subset of Azure by design. You get the core primitives, virtual machines, Kubernetes, local networking constructs, container registry, local key vault capabilities. You don't get the endless buffet of managed services that made people pick Azure in the first place. No one should pretend otherwise. Sovereignty is the decision to accept a smaller platform so authority stays local. The second cost is operational burden. You're now responsible for the lifecycle, patching, firmware, clustering, capacity, and recovery. There's no Microsoft will handle its story because that story requires connection. You will run incident reviews where the root cause is your own dependency graph, not the provider's. That's the trade. You wanted control, you got it. The third cost is change velocity. Cloud platforms evolve weakly because the provider controls the whole stack. Disconnected platforms evolve slowly because you control the stack, and controlled stacks move at the speed of governance. That isn't a bug. That's the mechanism that keeps random new dependency from showing up in your environment without permission. There's also a subtle design choice that matters, fleet management. If you deploy multiple disconnected Azure local clusters, you can optionally deploy a separate shared local control plane that manages them. That sounds like convenience, and it is, but it's also where sovereignty can collapse internally. You just recreated centralization. It's still your centralization inside your jurisdiction, which is the whole point. But you need to treat that shared control plane as crown jewels because it becomes the single choke point for policy, deployment, and identity integration across every cluster you own. The real win of disconnected Azure Local is continuity under duress. If the internet drops, if cross-border connectivity gets politically constrained, if your provider's control plane experiences an incident, if a contract dispute happens at the worst possible time, your environment still runs. Your tokens still get issued. Your workloads still schedule, your admins still have an authoritative interface. That's sovereignty as a system property. But it's also the cleanest way to expose the lie we started with. Sovereignty isn't something you buy from a hyperscaler. It's something you design by deciding which dependencies you refuse to accept. And once you accept that framing, the next uncomfortable question shows up fast. productivity workloads. Because infrastructure sovereignty is one thing, Microsoft 365 sovereignty is messier, and it breaks in uneven, predictable places. M365 local, sovereignty gains, and the parts that don't follow. Once the conversation moves from infrastructure to productivity, the tone shifts fast. People stop arguing about regions and start arguing about email. And that's fair because for most organizations, sovereignty doesn't mean Kubernetes. It means the things that get subpoenaed, leaked, and audited. Mail, documents, and collaboration trails. Microsoft 365 local is Microsoft admitting something the marketing never wants to say out loud. M365 isn't a single sovereignty state. It's a portfolio of workloads with different architectures, different dependency chains, and different places where control is centralized. So what do you actually gain with M365 local? You gain locality and operational control for a subset of workloads. Exchange, SharePoint, and Skype for business server running on Azure Local, that's the deal. Your mailbox databases and content stores sit on hardware you control. Your patch windows and change cadence become your problem again, which is the real marker of control. You can align backup, retention, and incident response to your jurisdiction without explaining to a regulator why the cloud is down or why support access required a process you don't own. That's real sovereignty value. For a lot of regulated environments, that's the whole requirement. Keep the content local, keep the operators local, keep the failure domain local. But notice what didn't happen. Microsoft did not make M365 sovereign. Microsoft made specific server products deployable on a cloud-shaped substrate you control. That distinction matters because people hear M365 local and assume the rest of the suite follows. It doesn't. Teams in particular is where the sovereignty story usually breaks. Real-time communications isn't a simple store data here problem. It's a distributed service problem. Signaling, presence, federation, meeting routing, media relays, compliance recording, and integration with the rest of Microsoft's global fabric. Even when Teams has strong data residency options in the public service, it remains Microsoft operated. And when your sovereignty requirement includes operational independence, Microsoft operated is the disqualifier, not the storage location. So organizations end up with an uneven portfolio. Sovereign mail and documents, non-sovereign real-time collaboration, or they restrict the collaboration features so hard that the business quietly roots around them with consumer tooling, which is how sovereignty programs create shadow IT and then act surprised about it. There's also the identity issue. Even in local deployments, identity doesn't magically become sovereign unless you make it so. If your M365 local deployment still depends on Cloud Entra for identity, you brought the decision engine back into the architecture. You moved the data plane. You didn't move the compiler. Disconnected Azure Local solved this by dragging identity and token issuance on-prem. M365 local inherits whichever identity model you anchor it to. So, a serious architecture treats identity as a first-class sovereignty control. Local identity authority if you require independence, or explicitly accepted cloud authority if your requirement is only residency plus governance. Then there's compliance reality. Regulators don't ask, is it Microsoft 365? They ask where data lives, who can access it, how access is approved, how it's logged, how it's recovered, and what happens under legal compulsion. M365 local improves your answers for content custody and for operational control because you can actually point at the systems and the workflows. But the unevenness creates a new burden, workload by workload governance. You now need to define a sovereign portfolio boundary. Which workloads are inside the sovereign boundary and which are outside? Which are allowed for what data classifications? What the approved collaboration patterns are between sovereign and non-sovereign services? What your e-discovery and retention posture becomes when half the estate is SaaS and half is local? And what your incident response playbook looks like when the breach surface spans both worlds. This is where most programs fail because they try to keep the story simple for executives. We moved to sovereign cloud. That sentence is always false. The real sentence is, we built a mixed sovereignty portfolio and we're enforcing the boundary with policy, identity, and governance. If you don't say it that way, you won't design it that way. So treat M365 local as what it is, a powerful tool for pulling specific data planes under your jurisdiction. Use it where mail and document custody is the requirement, except that the rest of M365 won't follow without trade-offs. And if your organization can't tolerate those trade-offs, at least be honest about the outcome. You don't have sovereign Microsoft 365. You have sovereign workloads and a list of exceptions that will try to become the default. Tenant isolation and metadata, logical walls, shared reality. Tenant isolation gets treated like a sovereign control because it sounds like a wall. A tenant, an isolated instance, a hard boundary. People hear that and assume physical separation, like their tenant lives in its own private building with a locked door. It doesn't. In Microsoft 365, tenant isolation is a logical enforcement model. It's identity and authorization doing the heavy lifting. Subscription ID boundaries, ACLs, service-side checks, and Entra-issued tokens that carry tenant context. That model works. It's how hyperscale multi-tenancy survives. But it's not the same as no shared reality. It's shared reality with rules. That distinction matters because sovereignty arguments often rely on the wrong mental image. They assume the provider can't see or touch things because the tenant is separate. In architectural terms, separation here is enforced by the authorization system, not by dedicated infrastructure. And metadata is where this becomes obvious. Most organizations focus on content, mailboxes, files, messages, but the cloud runs on metadata, directories, identifiers, routing tables, activity records, call detail records, compliance signals, and the little fragments of operational truth that make collaboration work. Much of that metadata does not live in neat, per-tenant physical partitions. It lives in shared systems with tenant-scoped authorization. So yes, your data can be region-bound and encrypted, and your tenant can be isolated, and you can still have a shared substrate where the only thing preventing cross-tenant exposure is correct enforcement. That is not an accusation, it's the architecture. It also explains why multi-geo doesn't magically make sovereignty complete. Multi-geo mostly governs data at rest placement for user content by preferred data location. But Entra remains centrally mastered. Directory objects and a lot of the tenant-wide metadata synchronize globally because the service needs global awareness for sharing, people search, and collaboration. That's how one tenant can function as one tenant across regions. So if your sovereignty narrative depends on everything stays in the geo, the directory and the service metadata will ruin your day because the platform optimizes for consistency and availability, not your legal story. Then there's auditing, which is where the platform quietly admits the trade. Some audit scenarios don't show up where people expect them to show up, especially across geos. Admins end up relying on broader audit views, like Purview's unified audit log, because mailbox level or workload level logs can have blind spots in cross-geo scenarios. Again, not broken, just not aligned to the simplistic everything is neatly local model. Now, layer in the 2026 shift. Power Platform Tenant Isolation Enforcement on February 1st, 2026. Microsoft moved Power Platform Tenant Isolation from optional governance control to default deny reality. Cross-tenant connections are blocked by default unless you explicitly allow list the tenant relationships. That's the correct direction, and it's overdue because cross-tenant connectors are a quiet exfiltration highway when credentials and delegated tokens can pivot between tenants. But don't confuse default deny with perfect isolation. The enforcement scope has edges. Power Platform Tenant Isolation only applies to connectors that use Entra-based authentication. If a connector uses a different auth model, it can sit outside this policy. And there are known gaps where enforcement doesn't bite the way you think it does. For example, the Azure DevOps connector has been called out as a case where the isolation policy isn't enforced because the OAuth flow uses its own token service rather than a token issued by Entra in the expected way. So the sovereign takeaway is blunt. Isolation controls operate at the layer they can see. Anything outside that layer becomes a policy exception by design. There's another uncomfortable corner, guests. Guest users and B2B collaboration don't behave like neat external equals blocked stories. Guests can operate inside a host-tenant boundary, and many isolation models don't treat that as cross-tenant movement because structurally it isn't. The guest becomes an identity inside the tenant context. That's convenient for collaboration. It's also how you accidentally import non-sovereign identity state into a sovereign environment and then pretend policy will sort it out. And even when isolation works, exceptions scale until they don't. Allow lists have limits. Power Platform Tenant Isolation allow lists have a finite number of entries. That's not a technical problem. That's a governance problem made visible. If your business model requires hundreds of cross-tenant dependencies, you don't have isolation. You have controlled permeability, and eventually you have uncontrolled permeability because people stop maintaining the list. So tenant isolation is necessary. It is not sufficient. It's a logical wall that depends on enforcement correctness, on connector coverage, on identity hygiene, on metadata realities, and on your ability to keep exceptions from becoming the architecture. Sovereignty demands something harsher. Treat the tenant boundary as a control surface, not a safety guarantee. Then design the rest of your architecture assuming shared reality exists, because it does. The default deny sovereign reference architecture. So here's the architecture that survives procurement cycles. Sovereignty is a default deny control model across 4 planes: legal exposure, identity authority, controlled plane authority, and cryptographic custody. Everything else is commentary. Regions, labels, boundary projects, partner clouds, compliance PDFs, they're inputs, they're not enforcement. Default deny starts with a design law. Minimize external authority, maximize verifiable control. If a pathway can bypass your intent, it will. Over time, it will become the pathway. That's not pessimism, that's entropy. Layer 1 is identity, because identity mints authority continuously. The sovereign pattern is separate token issuance authority from business convenience. That means you define tenants as sovereignty domains, not org charts. If you can't do that, then you treat privileged identity as its own sovereignty domain inside the tenant. Separate admin identities, separate admin workstations, separate conditional access scopes, and separate break glass accounts that are actually scoped and monitored. Then you reduce policy surface. Conditional access minimalism is not aesthetic, it's determinism. Fewer policies, fewer exceptions, fewer scopes. You stop writing policies like legal documents and start writing them like compiled code, small, composable, testable. And you enforce change control like you mean it, policy as code where possible, report only to validate behavior, and deliberate acceptance that temporary exclusions require an expiration and a rollback. You also back up the sovereign state of identity, not export for documentation. Actual versioned restore. Policies, named locations, authentication strengths, cross-tenant access settings, admin consent grants, and the groups that scope all of it. Sovereignty without rollback is an availability story that collapses during the first bad change. Layer 2 is control plane minimization. This is where most orgs lie to themselves because they want global admin convenience. Sovereign control plane means you shrink the number of identities that can mutate reality, and you shrink the surfaces through which they can do it. That means strict RBAC and scope boundaries. Management groups and subscriptions align to sovereignty domains, with deny assignments and policy guardrails to prevent cross-boundary deployment and replication features you didn't intend. It means PIM for everything privileged, with activation requiring strong auth and approval, and with just-in-time access that expires automatically. It means you treat automation identities as production-grade attack paths. No broad graph permissions by default, no long-lived secrets, and no just give it owner, it's blocking the pipeline. It also means you separate observation from mutation. Monitoring identities shouldn't be able to deploy. Deployment identities shouldn't be able to grant roles. Support workflows shouldn't be able to release keys. This is how you keep the control plane from turning into a single privileged blob. Layer 3 is cryptographic sovereignty. Encryption at rest is table stakes. Customer-managed keys are better, but default deny sovereignty requires custody and controlled release. Keys that you hold, with a release mechanism that requires your participation and, ideally, a runtime verification step before decryption occurs. In Azure terms, this pushes you toward HSM-backed keys, where the provider can't extract key material, and toward secure key release patterns that only release keys into attested confidential compute states when your threat model includes operator access or compelled disclosure. The important part isn't the SKU. The important part is the property. A compelled data handover yields ciphertext that stays ciphertext because the decryption authority doesn't live in the same admin surface being compelled. Layer 4 is telemetry and operations, because sovereignty fails through helpful data movement. You classify telemetry like data. What logs can leave the domain? What must stay local? What must be redacted? And what retention is required? You avoid centralizing logs across jurisdictions just because it makes dashboards easier. Dashboards are not a sovereignty requirement. Control is. Then you decide what hybrid means. Azure Arc can enforce sovereignty or it can erase it. In the reference architecture, Arc onboarding is scoped to sovereignty domains, not to the enterprise. Policies are assigned narrowly. Extensions are controlled. And any capability that pushes configuration at scale is treated like a production deployment system, approved, audited, and reversible. Finally, you pick the deployment model that matches your actual sovereignty requirement, not the marketing one. If you need residency plus governance, sovereign public cloud controls can be sufficient when coupled with key custody and strong identity constraints. If you need operational independence, no external dependencies, then the architecture ends at disconnected Azure local patterns because that's where control plane and identity authority move under your roof. The outcome is simple. Every pathway that can create authority, change policy, release keys, or exfiltrate truth is either denied by default or gated by a workflow you control. That's sovereignty, not a region, not a logo, a system that refuses to do things unless you explicitly allow it. Sovereignty is enforceable authority over identity control planes, data planes, and keys, not a region label or a vendor promise. If you want the practical blueprint, watch the next episode on building a default deny landing zone. Identity scopes, control plane minimization, key custody, and rollback as a first-class security control.